I see a lot of mistakes when students draw resonance structures, and so I wanted to make a video on some of the more common mistakes that I've seen. So let's say we wanted to draw a resonance structure for this carbocation. Some students would take these electrons and move them down to here and say, all right, so on the right, now I would have this, and this is my resonance structure. Let me highlight those electrons in blue here. So these electrons here move down to here. But this is incorrect. So let me write no here. So the resonance structure on the right, this is an incorrect resonance structure. Why is this resonance structure not possible? Well, let's draw in the hydrogens on the carbons, and it'll be much more obvious. So this carbon right here has one hydrogen on it, same with this carbon. And this carbon right here has two hydrogens on it. And the carbon with a +1 formal charge must have one hydrogen. So let's put in those hydrogens for the resonance structure on the right, and it should be obvious why this resonance structure is incorrect. Let's focus in on this carbon right here, the one I marked in red. How many bonds are there to that carbon? Well, here's one bond, 2, 3, 4, and 5. That's 5 bonds to a carbon. That does not happen. You can't show carbon with 5 bonds because that would be 10 electrons around this carbon, and carbon can never exceed an octet of electrons. Because of carbon's position on the periodic table, in the second period, there's 4 orbitals, and each orbital can hold a maximum of 2 electrons, which gives us 4 times 2, which is 8. So carbon can never exceed an octet. Well, there's another reason why this is wrong. If we go to this top carbon here, there's only 3 bonds around that carbon. So that carbon would have a +1 formal charge. So we added another formal charge, and we have carbon with 5 bonds. So this is incorrect. This is not a correct resonance structure. So what is the proper resonance structure to draw? Well, let's show that down here. You take your electrons and you move them in the direction of the positive charge, of the +1 formal charge. And so let's show that. So the electrons in, let me make them blue again. The electrons in blue, move over to here like that. And that moves the positive formal charge over to this carbon. All right, if we draw in our hydrogens, it'll be clear why this is correct. So we put in a hydrogen here, we put in a hydrogen here, and we put in a hydrogen here. So let me draw in those 3 hydrogens on the right. Okay, now it's very obvious. Let me point this out in red. It's obvious that this carbon here in red has a +1 formal charge. It has 3 bonds around it. So 1, 2, and 3. And this carbon over here on the right that had the +1 formal charge, now its formal charge is 0, because there are 4 bonds around it. So 1, 2, 3, and 4. So now the formal charge is 0. So this is the correct resonance structure. Now it looks a little bit confusing when I have those hydrogens drawn in there, which is why we leave them off. Let me go ahead and draw it again on the right just for clarity. That's why we leave off those hydrogens when we're drawing our resonance structures, because they get in the way. And once you understand what's going on, it's not necessary to draw in those hydrogens. Let's do another example, and again, I'll start with the wrong way to do it, and then we'll talk about the correct way. So a student might say, all right, I have a -1 formal charge on this nitrogen, so I could take this lone pair of electrons and move it into here, which would push these electrons over to here. So let me go ahead and draw what some students might think is a correct resonance structure. So let me put in my lone pair of electrons. Let's follow some electrons along. So electrons in light blue on this nitrogen move into here, and electrons in, let's say, dark blue move down to here, and then finally electrons in magenta remain behind on the nitrogen. So on the right, why is this not a correct resonance structure? So again, this is the wrong way to do it. Well, think about your hydrogens. So we'll start with this carbon right here. This carbon has 1 hydrogen, this carbon has 1 hydrogen, and this carbon down here has 2. So if we put in those hydrogens over here on the right, hopefully it's obvious why this is incorrect. Right, let's look at this carbon down at the bottom of the ring. So this carbon right here I just marked in red. How many bonds do we have? Well, here's 1, 2, 3, 4, and 5. So there are 5 bonds to that carbon, and we know carbon can never have 5 bonds. Carbon can never exceed an octet of electrons. So immediately we know that this is not a correct resonance structure. All right, let's talk about the right way to do it. So you take these electrons and you move them into here, and then these pi electrons have to go somewhere, and they move out onto this carbon. So now let's draw the correct other resonance structure here. So we'll put in our double bond. We'll put our electrons on this carbon. That gives this carbon a -1 formal charge, and then we had some electrons, a lone pair of electrons left on the nitrogen. I'll use the same colors as before, so these electrons right here in light blue move in to form our double bond. The electrons in dark blue move off onto this carbon. So the electrons in dark blue are on this carbon that I just marked in dark blue, which gives that carbon a -1 formal charge. And the electrons in magenta remain behind on the nitrogen. All right, the reason why the carbon, now I'll go ahead and mark it in a different color. This carbon I just marked in magenta has a -1 formal charge is because, remember, there's 1 hydrogen on that carbon. So let me draw on that hydrogen over here. All right, let me see if I can squeeze it in over here like that. This carbon right here has 3 bonds to it and a lone pair of electrons, which gives that carbon in magenta a -1 formal charge. Now, this nitrogen over here would have a formal charge equal to 0. And so this on the right would be the correct resonance structure. And again, drawing in hydrogens is a waste of time, right? It gets in the way. Let me go ahead and draw the resonance structure again. I'll take out that hydrogen so it'll look cleaner. Right? It also takes less time when you're not drawing in all of your hydrogens. So you just put a lone pair of electrons and write a -1 formal charge, and you have to know that there's still a hydrogen on this carbon that I marked in magenta. So if you're having trouble drawing resonance structures, usually the problem is not thinking about your hydrogens, right? Forgetting about putting in your hydrogens. And once you put those in, it's a lot easier to see if your resonance structure, I should say, is correct. So be careful about that. And resonance structures are just practice. So the more you draw, the better you're going to get. And if you make a mistake, it's not a big deal, right? You learn from your mistake and you keep on practicing.